Here we are at example 5 from our 5.2 number 2 set of notes. We're asked to graph the following function by making a table of values and then just pretty much talking about the end behavior of that. So in just kind of looking at our function, I'm going to choose some random x values, like maybe we'll go with negative 2, negative 1, 0, 1, 2, 3, and 4. I like positive values better. Now, if we go ahead and throw in negative 2, we end up with negative 2 cubed. That gives us negative 8. So negative 8 minus 3 times negative 2 squared gives us positive 4 plus negative 2 plus 1. We end up then with negative 8 minus 12 minus 2 plus 1. So negative 20, negative 22, negative 21. We throw negative 2 in there. For negative 1, when we put him inside, we end up with negative 1 cubed as negative 1 minus 3 times negative 1 squared is positive 1 plus negative 1 plus 1. So it looks like we end up with negative 1 minus 3 minus 1 plus 1. So negative 4, negative 5, negative 4 as a result. When we plug in 0, nice thing about 0, this is gone, gone, gone. Just that last value, 1. If we go ahead and plug 1 in, we end up with 1 cubed is 1 minus 3 times 1 squared is just 1 plus 1 plus 1. So this comes out to be 1 minus 3 plus 1 plus 1. So it looks like it comes out to be 0. Throwing 2 in there, we'll change up colors so we can see a little bit better. Throwing 2 inside, we end up then with 2 cubed is 8 minus 3 times 2 squared is 4 plus 2 plus 1. Looks like then 8 minus 12 plus 2 plus 1. So negative 4, negative 2, negative 1 would be that y value. Looking at 3 and plugging that in, we end up with, we'll change colors again. Go purple this time. 3 cubed is 27 minus 3 times 3 cubed. So that would be 9, negative 3 times 9, plus 3 plus 1. So we'd end up then with 27 minus 27 plus 3 plus 1. So these will just cancel out with one another, giving us 4. And then lastly, throwing 4 inside there. Go with green again. 4 cubed gives us 64 minus 3 times 4 squared is 16 plus 4 plus 1. So we have 64 minus 3 times 16 gives us 48 plus 4 plus 1. So 64 minus 48 gives us 16 plus 4 plus 1. So it looks like 21. Now, for some of these like side ones, at the very, very ends, I think what we'll do is we'll kind of leave them alone, or maybe draw like a really rough sketch of a point, but we're not actually going to graph those just because they're really, really high or really, really small for their y values. At least in terms of like to scale, I should say. But for all the other guys in between, we can graph those just fine. So we have negative 1, negative 4. We'll start off with him. Negative 1, negative 4. There he is. 0, 1. Right there. 1, 0. Right there. 2, negative 1. There he is. 3, 4. And then finally, 421 will be way up here somewhere. We'll just say he's right there. For the -2, -21, we'll just say he's down here somewhere. So then, when we connect all the dots, we would see, again, this is just going to be a really rough sketch, just a rough image of this thing. We would see something like this. All right, now let's talk about some of the end behavior here. Well, as always, we start off with, as x goes towards infinity, f of x is doing what? Well, just from the graph, we see that as x is going towards infinity, so as x is going outwards this way, we see that our f of x, or our y values, are going up and up and up and up towards positive infinity. Alternatively, as x goes towards negative infinity, our f of x is doing what? So in other words, as we go outwards towards the left, towards negative infinity for x, we see that we are going down towards negative infinity for our y values, or our f of x values. So this would be our end behavior. Again, that is example 5 from our 5.2 number 2 set of notes.